You flip a switch, light floods the room. You plug in your phone, it charges. You click a link. Data streams across continents in milliseconds. Every single one of these moments, these tiny mundane acts you perform dozens of times every day, depends on something you probably never think about. Cables. Miles and miles and miles of cables. Woven through the walls of your house. Buried under the streets. Strung between towers marching across landscapes. Snaking through the depths of oceans. Running through every building, every vehicle, every device. The global wire and cable market is worth over $230 billion annually and growing. That's not million, billion, with a B. Based on industry production volumes, manufacturers around the world produce enough cable each year that if you could somehow lay it all end to end, it would likely wrap around Earth's equator many times over. And here's what gets me. Most people have absolutely no idea how these cables get made. They see the finished product at the hardware store, coiled neatly on a spool, and assume it's simple. Just some copper wrapped in plastic, right? Wrong. Dead wrong. The process of turning raw materials into the cables that power modern civilization is an intricate ballet of physics, chemistry, and engineering precision that would make your head spin. A single power cable contains components that have traveled through a dozen different machines, been heated to temperatures that could melt steel, stretched thinner than human hair, twisted together with millimeter precision, coated in multiple layers of specialized plastics, tested with voltages that could kill you instantly, and inspected by systems that can detect defects smaller than a grain of sand. All of this happens at speeds that would seem impossible if you weren't watching it happen. Some cable production lines run at over 1,500 meters per minute. That's faster than most cars on the highway. And every single centimeter of that cable needs to be perfect. Because when cables fail, bad things happen. Buildings lose power. Data gets corrupted. Communications go dark. In the worst cases, people die. So, how does this industry pull off this feat of manufacturing magic? How do you take chunks of metal or pulled from mines on one continent and transform them into the nervous system of modern society? Buckle up, because what happens inside a cable factory is way more intense than you think. Before we dive in, drop a comment and let us know where you're watching from. We'd love to hear from you. If you enjoy stories like this, be sure to like the video, subscribe, turn on the notification bell, and share it with someone who'd love it too. Every cable starts with metal. Lots of it. The two primary conductors used in cable manufacturing are copper and aluminum, and the choice between them shapes everything that follows. Copper dominates the market, accounting for over 60% of all conductor material used in cable manufacturing globally. Why? Because copper is phenomenal at conducting electricity. It has one of the highest electrical conductivities of any non-precious metal on Earth. When you need to move electrical current from point A to point B with minimal energy loss, copper is your best friend. It's also incredibly ductile, meaning it can be drawn into extremely thin wires without breaking. This combination of high conductivity and mechanical workability makes copper the gold standard for electrical wiring. But copper comes with a problem. It's expensive. The London Metal Exchange tracks copper prices daily, and they fluctuate wildly based on global supply and demand. In May of 2024, copper prices soared to over $5 per pound, causing cable manufacturers to raise their prices significantly, with some reporting increases approaching 45%. Mining companies extract copper ore from massive open pit or underground mines, primarily located in Chile, Peru, China, and the United States. Chile alone produces about 5.5 million tons of copper annually, making it the world's largest producer. The raw ore typically contains only about 1 to 2% actual copper. The rest is worthless rock that needs to be separated out.